they make an assumption that I don't want you to make. I know that the change in potential, delta V, is going to be V final minus V initial. Because it's change. Change is always final minus initial. Electric potential is based upon that formula, but remember, my potential energy formula here, I left off the plus a constant. There's actually technically plus a constant here. So just like I can make my potential energy 0 wherever I want, I can make my electric potential 0 wherever I want. And so the general thinking is, well, you know what? Let my initial potential be 0, and so therefore delta V is just equal to my V final, and since I have only one V there, we'll just let delta V equal V. Some textbooks are very picky about that, and they put the deltas in where they belong. Some textbooks, less so, and I think your textbook is less so. Just please be careful. When you see a formula for V, sometimes it's a delta V, even though the delta's hidden.
I will find it and put the triangle, the delta, where it needs to be.
Whoever, yeah. I would, it'd be cool if everybody went in and put the deltas where they're supposed to go. So if I have a 12-volt battery, let's make it this way, I'll make that one better. Positive and negative side. A 12-volt battery tells me the potential difference from here to here is 12 volts. So this bottom one could be 0 volts, and that could be 12 volts. Or maybe the bottom one is negative 20 volts, which means the top one is negative 2 volts, or negative 12 volts. Or, sorry, negative 8 volts. When I learned to do math, it'll be cool. All I know is that the positive side is a higher potential by 12 volts from the bottom side, if this is a 12-volt battery.
Okay, say that one more time. So if you said the 12,
If it's a 12-volt battery, it is voltage. All that says is that the positive side is 12 volts more than the negative side.
all this means.
Yeah. Because when it comes down to pushing charge, the potential energy is not particularly important, it's the potential difference.
Is it always the positive that's going to be higher?
Yes.
Okay.
Yes. One of those few always.
Yeah. And so the voltage on that battery is 12 volts,
Yes.
because it's 12 is the difference between those two.
Yes.
Okay.
All right. Now the questions to hear before I talk about what I skipped over that we have to hit on Monday. Questions? So we started out with opposites attract like repels. So we explained why two charges would attract or repel based upon the force. We then talked about why they would attract or repel based upon the electric field. There is an explanation for why they would attract or repel based upon the potential energy and based upon the electric potential. So those need to go over on Monday. One other thing that the textbook doesn't go into, but it's going to be helpful, is we need to talk about electric flux. And so just sort of imagine, I know the second alarm has not gone off quite yet. Imagine, think of an electric field as arrows. And that would be the cliffhanger. See you Monday. When did you send it?
6 or 7.
Oh, yeah.
Hebrew, he made a thing on Blackboard this morning that you can just turn on the graphs.
Oh.
Do that.
Okay, woo!
Also.
No, it was a conceptual question where they had a chance to talk with it.
We did.
I will desperately try to remember to post it so that you can pull it down and answer questions.
I tried to find where we could put.
Yeah, it's there now. It's everything you need to.
I'll look at it.
All right, I need to. Okay, when I get to my office, I will post it. Before I show anybody what the grades are or anything else.
You don't have to ask that question. In the coming weeks, I will.
All right, your family.
However, we ended up, stopping our care with 3%
Yeah, what was your slope?
Yeah, I found the slope. I needed to, that's what it
No,
should.
that's what it should be. What was your slope?
What was my slope? Okay, so for one of them, it was, negative 3.41. The other one, it was, I think,
150 million.
most likely.
Large, it was a large number.
What is that paper?
Yeah, it's the negative three point
What is it
something.
called?
So you got
Or
a
what's it-
nice little
you
separate
wanna
house
post
there.
it on something?
Yes. Is that the
It's
goal?
It's because you were reading too hard.
Yeah.
How many times have we told you not to breathe during lab?
more like. Not more of a mess. Yeah. Is it? I'm sorry.
Alright, so
Also go on the textbook and look up.
I know that the
If you go to
force
like the
is
sections,
proportional
you have
to,
to chapter 18.
the
It takes a
angle.
I mean, that's what I'm hearing.
So force equals some constant,
You want to take a picture of the advantage?
the torsion constant minus theta. It's a little bit off, but I'm good with it.
Upside down.
All right. I know the force is also proportional to one of our
I went to and from the tech.
No, one of our square.
Third floor twice,
So-
and then I bolted from.
One over
tech
that, so
to.
one over the top. So therefore, force is equal to K Q, K E, Q1, Q2, R to the negative two. Therefore, that are equal to. Okay, thank you. So I have K T theta is equal to K T Q1, Q2, R to the negative two. That's just some constant for the problem. That's just some constant, which you actually find.
Yeah, I think I found right, like what I found right here, right?
Yeah.
The number that small is that?
Yeah, it doesn't need a whole lot of force in order to twist it. All right. So therefore, theta is just equal to some constant by that, call it Q4. Negative 2. That's the relationship we're testing. If you take the log of both sides, you get a natural log of theta, you get a natural log of r, you're eventually gonna end up, you're looking for a natural log of theta, except your vertical.
Yeah, it was the Y.
Is equal to something times the natural log of r plus something.
And then that would be the slope.
Yes.
This, what really messed me up is I thought I was looking for some sort of constant here. No, this is particularly to the problem that we put, and,
Well, actually, theoretically, it is a constant here.
yeah. But, oh, also, you forgot the log stuffs. That,
That's
and then
correct.
one, give you. Those two, bingo, mango, do that, make it a lot easier.
You remember that stuff?
Yeah.
Okay.
Alright. Oh, you were next.
Just, I had to say that question, I was just.
Okay.
Oh.
Start out, pick the natural log of both sides,
Oh, theta and
and then get for r to the negative 2.
So is r to the negative 2 1 over r?